Hello and welcome back, and today we're going to revisit the Brymen BM235 with that whining noise, which has been traced down to C44, which is a ceramic capacitor. It's explained in Dave Jones' EEVBlog YouTube blogging channel. Actually, he just recently did a video on it, as well as back on, I think it was video 30 or 33, when YouTube was restricted to about 10 minutes of video. He had to actually splice it up into two parts. Anyway, he replaced the capacitors quite successfully, but he had a meter that had a medium whine, I would say, or possibly a low whine, where this one obviously is, well, I'll just turn it on for you, and then you can decide. So it was obvious before I even brought the mic into the video previously, and a couple things from his video actually kind of made me think, well, one, we can go ahead and replace the capacitor, because at this point I'm not worried about the warranty. I think it'll make a better, more interesting video. I'm not usually doing repair videos or fix-it videos or teardown videos. It's not my thing. I leave that to the guys that can actually look at a circuit board and reverse engineer it like Dave on the fly, and just tell you this does this, and this is why this filter's here, and this is this kind of filter and design, and this feeds this, and blah blah blah. Now, I'm still, I'll admit, quite new in the electronic repair hobby kind of side of things, as far as electronics and gadgetry and engineering on other aspects of things. Yeah, I've been professionally involved in computers for longer than I like to admit. As of, oh, I don't even know. I think since I was like maybe 10 years old, I've been taking things apart, putting them back together, getting grounded for it, and the one thing that amazed my family the most is the fact that when it was put back together, it actually worked. And of course I got grounded because I didn't ask if I could take it apart. It was a natural curiosity as I was a kid. But as far as explaining it to you, there's no point of me taking something apart. Yeah, I take a lot of my stuff apart. But what's the point of me taking something apart if I just say, ta-da, here's the inside? I mean, to me, it satisfies a certain level of curiosity that I have with certain devices. I admit that. That's why I do it. But to you, the viewer, well, it doesn't do you any good. So I stay away from those kind of videos typically. But as far as one of my main things about probing this meter originally to trace whether it was or was not the inductor on that I'll call that a semi-delirious, well, no, majorly delirious on my part, semi-teardown video that I released. I'd say the one thing that kept me from actually probing it is the fact that I know for a fact this thing on the continuity puts out about 7.5 volts, and same thing with ohms. My Fluke puts out about 5 volts. Some of my X-Techs may put out about 4.5. The cheap yellow meter buried behind the blue case here that I found in a garage one day, that's actually quite accurate, surprisingly, and still has the old green backlight. That puts out about 3.5 volts. I didn't want to go throwing any type of voltage into the circuit, and knowing that it does have LEDs, I know there's an LED driver. It's just a fact. I have probably close to 25 flashlights behind me on my other bench, LED flashlights, anything. I have flashlights that put out close to 2,500 lums and draw up to 3 to 4 amps on a single 18650 lithium-ion battery cell. And I didn't want to take a chance. I've shorted LED drivers before by doing something stupid, and I didn't want to do that to this meter. Now, Dave supports taking apart the meter, of course. It says it in his manual. Warranty void if you do not take it apart, I believe, are the words or something to that point that he actually puts in his green text on his PDF version manual under Dave Notes at the very end of the manual. So of course, taking it apart, I wasn't fearing that it was going to void warranty, but probing it and introducing voltage and maybe not probing it in the right place or damaging the driver chip for the LEDs, well, that's on me. I'm not going to go back to the reseller or the manufacturer and say, hey, my backlight stopped working, especially when I probably did it on video, and I was probably stupid enough to release the video showing that I did it too. As far as warranty goes, let's forget about it. Let's just forget about it completely. Like, I don't have enough meters on my desk as it is. I love this meter. Honestly, this has been one of the most impressive, best sub $100 meters, or about $100 that I've ever owned. But despite my fondness of my first Brymen meter, I'm going to go ahead and take it apart again. And we're going to either end up replacing that capacitor, which I believe I did find another 1206 surface mount cap that will fit the needs. I believe it's probably a 10 microfarad rated according to the data sheet, which is required. But at the same time, I'm only measuring it at about 9, which is typical within, you know, depending if it's a 5%, 10% capacitor. So I'm going to try that in its place, but there's something else I want to try before I go there. I'm going to fire up the hot air machine, the rework station, and I want to actually just see if possibly the reason some meters whine louder than others might be because my capacitor is slightly lifted off the PCB board and it's causing more of some sort of amplifier echo off the board, where if the cap is soldered and it's actually perfectly flat on the board, the PCB board may be acting as a dampener and actually absorbing some of the vibration noise that's being heard in the capacitor. So before I go replacing it, I actually just want to kind of, oops, apparently little looser. Before I go replacing it, the first thing I want to do is kind of just reflow it and then turn it back on compared to the beginning of the video, which you just heard it, and see if that makes a difference. If that makes a difference, then I'm okay with using this cap, despite, you know, the fact that it's probably only a 5-volt capacitor because of the height of it. You know, compared to the one I'm going to put on there, it looks more like a 25-volt cap because of the thickness and the amount of layers in the capacitor that I found that will be the replacement for it. So let's go ahead and do the reflow and see if that's all I need to actually make a difference. Unlike the last video, this time you actually get to see me tear it down from the beginning. Yay! I'll probably fast forward through this. You've probably already seen this. Well, if not with me, with Dave or somebody else at this point. Let's go ahead and push these boards back down. And that should do it. Oh, nope. Wait, I forgot. The hidden one under thy fuse. And of course, my previous two videos, the one semi-tear down, and then there's the other video, which was the review. I pretty much have a nice set of data between those two videos with the accuracy, with the voltage reference, and my buttons decided to come with it this time. And of course, all the washers except for one this time. One washer decided to stay on the board. Let's put the buttons back down there. Thank you. I don't need the buttons. But I have a nice set of data to basically compare this to in the end, to go through and do the same exact accuracy tests that I've ran previously. So we'll know if the meter has been changed in its accuracy at all, which hopefully it won't be. I'm kind of hoping, counting on that, because I really do like the accuracy of this meter. I like the size. There's a lot I like about it. The only thing I think is missing is duty cycle, that I use frequently, by being somebody that builds LED flashlights, of course, because you know, that's pretty much the control of the driver, is the duty cycle and the pulse width modulation being sent to the LED to control the brightness of the luminosity. So it's a shame I can't use it for that, but either way. Now, before I continue, I do want to kind of make clear real quick. I've gone through every kind of piece of new stock that I own as far as resistors, capacitors. Put these up out of the way. I got these sample books. These are not the right size. These are 603s anyway. These are Yageo capacitor and resistors, and the sample book happens to go up to is 1 microfarad. I already have a bunch of 1206 parts sorted in here, capacitors and resistors as well, is all marked and everything. You can hear them if I shake them around. Again, 1 microfarad's the largest I have. So if we do end up replacing the capacitor, the one I'm replacing it with was actually pulled off a donor board or a scrap board, just something I kind of keep around for, yeah, you know, who knows, there might be a part on there I might need someday, and or maybe I got a new soldering iron and I need to do some practicing with it. That's basically why. Actually, that's more why I keep those boards around. They're great practice boards, they're great teaching boards, you know, pulling parts off, putting parts on. And if I could remember where I put that, there it is. Worst case scenario, I do have a 30 farad cap, or 30 microfarad, but here's I think it came out to be 9.1, I think it said it was. Basically it's a 10. So we'll leave this over here for right now. We'll try the reflow first and see if that corrects it. But I do get to use something you have not seen in a previous video and I have not done a review on yet. But I like it. I like it a lot. And I really haven't used it in practice yet. Well, except for today. So we're going to see how it works in practice. Let me bring it out. And there we go. It is my AmScope microscope. And it is big and it is a beauty at the same time. Like I said, I like it a lot. Let's back off the magnification so I can figure out where I'm at here. There we go. Oh wow, that's beautiful. Now I also have a camera on this. It's a slow camera. I don't know what the frame rate would be. It's a 3 megapixel camera. Haven't quite tried it out at that depth yet to see how it would handle shooting videos, but I did get the software to recently install on Windows 10, which was a trick because officially it's not supported by Windows 10. I'm not going to use the camera today. We're just going to use this to take some of the stress off my eyes, and oh, I can actually see a full flux trace along there. Maybe I should use the camera. As far as the space goes in the board, there is indeed, I can see a batch of flux underneath the capacitor, and there is a space there which may be acting somewhat as an amplifier to the actual natural hum of that capacitor and making mine appear louder than others. So I say we heat this up and just drop this flat all the way down, maybe even pull it off and clear some of that old flux off of there. You know, I'm going to actually take a picture of it with the microscope camera. I don't know how the videos work yet. As I mentioned, haven't gone there. But I will switch off of this camera for a second and I'll go back over just to take a picture of it so you can see that kind of same space I'm talking about that may be in question, that may actually be a fix enough. I mean, I expect a little hum. So we're just going to kind of reflow this and set it back down, maybe pull it off, take a measurement, see if the cap I have to replace it, the 9 microfarad will probably do. This is probably a 10% or a 5% cap itself. Just reflow, put it back down, turn it back on, put it back together, turn it back on, and compare it to the beginning of the video as far as the audio that was announced when I turned on the backlight, and see if it makes a difference by just reflowing this. So let's go ahead and give that a shot. Now unfortunately I don't know if I should actually try to do this under recording a video with the microscope or not, but I guess I could technically try to do it. Wow, this thing gets quite close, and I'm not even at full magnification. There's a different Barlow lens I could put on there that could show much better. You can tell the frame rate's a little slow as I'm trying to adjust the focus here. It's kind of playing catch up. I'm adjusting it one way and it's adjusting a different way. And this is the flux trail I spoke of in the beginning of the video. Let's change that lighting again. Turn that lighting up. I'm going to have to Trying to focus on the actual PCB itself. You can see this flux trail leading off here and around, and it starts over here, and it just kind of gathered this puddle underneath this, which may have left this suspended slightly from the PCB board here in this case. So we're going to clean this up as well with some isopropyl alcohol and try to get that flux trace off of there as well. So we'll remove the cap to do that work. This is very interesting working under a microscope. I've never actually worked under a microscope before, but I figured if I was going to spend the money on a microscope, I might as well also spend the money on a camera and see if I can incorporate this into some of my videos as well. And, well, that's what I'm doing. Move my studio lighting out of the way. I guess I'm going to have to tweeze left-handedly because of where the microscope kind of positions me here. That should be interesting. Tweezing left-handed. As you may have guessed, my dominant hand is not my left. Start from a distance. Warm things up. Go around the outside and the top. Try to get the board nice and warm. Kind of a preheat. Oh wow, it's really weird looking away from the microscope back into a different lighting altogether. Your eyes definitely kind of go a little funky there trying to refocus things. Something I'll need to get used to. I definitely enjoy working under it. It seems like it's definitely a lot easier to do the smaller things. I say we let it cool down and see. Oops, I saw it lift. See, I saw it lift. I don't want it to lift. I should have kept my tweezers on there just a little bit longer, because I do want that to be flush, hard against that board. See my tweezers with that pressure on there. Keep that pushed down. Notice that when I put my tweezers off too early, the capacitor lifted up as the solder hardened and cooled down, so then I redid it and kept pressure on it so I can keep it against the board. Or maybe it needs to be away from the board, so maybe the board was acting as the amplifier and I'm actually thinking backwards, so maybe it needs to be a little higher. Maybe it needs to have that little gap so it has nothing to reverb off of. But there's only one way to find out. Let's go ahead and put it back together. I don't hear it. I have a backlight. Oh, it's there. It's there, but now I'm acting like Dave. I gotta get my tongue in the right position here. Noticeably, let me turn off the oscilloscope. It's there, but it's not as loud. There was an actual change just by reflowing it. I heard it over my oscilloscope last time. This time, I kind of hear it, but not really. I would have to be in a dead silent place. In fact, I'm not even sure if you can hear it at this point. Well, you know, there's another factor. Put this on. See if that drowns out the little bit of pitch that I still do hear. But I have to listen really close to hear it. Let's go back to it. Now I think I know what Dave was talking about when he said that he could barely hear his. And I used the same capacitor. All we did was reflow. We just resat it down. And made sure there was no gap in between the cap and the PCB board that might have been acting as an echo board to amplify the sound of the actual capacitor oscillating or vibrating. Oh yeah, I'm okay with this. I don't need to change the cap. I could tolerate this. But the fact that I don't hear it here, now I wonder if the microphone's picking it up and if you guys can hear it on the video. Let's go ahead and let's bring the microphone down. Let's see if you guys can hear it. Because I'm assuming right now you can't hear it on the mic like you did last time when I turned it on and off. So I'm going to try to bring the mic in. And it should be right about there. So if it is picking it up, then as I bring the mic away, the mic would be at a more natural setting of where my ears are, which means you probably don't hear it anymore. So it turns out it may not be a factor of quality of the capacitor. I think all the capacitors on these meters are making that hum, that vibration, but it's the difference between how loud one meter seems to be versus another. That's what got my curiosity up on thinking maybe it's how it's been soldered to the board. There could be a slight difference in how close the capacitor is actually on the PCB board or above it. You know, is one causing a dampener effect? Is one causing an amplifying effect, an echoing effect? There you have it. Same capacitor. And now I'm pretty sure what I'm hearing is pretty much what Dave heard. Which, in truth be told, that this is not bad. This does not bother me. This would have to be dead, complete dead silence for this to bother me. And it's not. It's never going to be complete dead silence, so yeah. I don't mind the way this sounds right now. Let's plug the probes in. Let's make sure we didn't change anything with the accuracy of this, because it's one of the main features I love about this meter. Thanks for watching. Hope you enjoyed this video, and go ahead and give me a thumbs up, click subscribe, what have you, leave comments down below, participate on the EEVBlog. I encourage you to at least join the EEVBlog and go ahead and pick people's brains over there. There's a lot of great knowledge over there. Definitely a good learning experience, good reference if you ever want to if you ever need a soundboard to bounce an idea off of. Soundboard. It's a good forum. Good people in general. It really is. So thanks for watching and keep on tinkering.